Okay, time for another video from the Unwatched Video channel. This one is what we call a Prairie Schooner. It's a lightweight, fairly lightweight animal shelter for us to grow turkeys, but you can grow chickens or goats or sheep. I think alpacas are probably too big. A llama's definitely too big. This is a 3D view of it. There's individual trusses. This is done with 78-inch spacing, which seems to be we have typhoons here in the Philippines, so I wouldn't go to the 117-inch spacing just because you could. This is the frame. It would have a metal building tin, 3 sheets up here and 1 sheet there, and the bottom is a roll up, roll down billboard tarpaulin. Tough enough for a billboard is tough enough for this, and it's outdoor, ready for the sun. We'll get into some look at the individual things in an end view and side view. This is a side view, and it's showing like the spacing between the individual frames. They're not all the same because our building tin here is 6 meters, and we want a 10-inch overlap. So the middle section, the middle 6-meter section, is centered on these. Run out to the edge of the clip. Clips are 10 inches long. Clips what is it's welded onto the truss frame, and these blue and green things bolt to it. They can take this thing back apart or put it together so it bolts, but the bolts are all in shear, so it's got it locked together pretty tight even if the nuts were loose. Okay, so the sheet metal is going to go from the edge of a clip to the edge of a clip, and this piece of sheet metal is going to go to the other side of the clip. That gives 10 inches overlap, and sheet metal hangs past the end here where we can put a end sheet metal on it. The clips are slid in to only have, I think it's 1.5 inches past frame. Yeah, 1.5 inches past whatever this thing is apart. So it's 70, a couple of 78s. That's the nominal length between them is 78. Then we have the 72.5. That's to get the sheet metal lap. 78, then another 72.5. That gives us a lap on this end. A couple 78s and it ends with a 70. The clip is all this angle and every piece in it is 1.5 inches by 1.5 inches by 3/16. If you're capable of welding 1/8 without making a mess out of it, you could build this out of 1/8. Our guy, what are we using? 122 or 126 thick. He can do it, but we decided we'd make it a little thicker. Wasn't that much money, difference in money. Anyway, there's notes on this sheet. We'll probably pause over them to read them. But this is just the dimension off the edge of the angle iron, and then these dimensions are in from the end, and it's not written down. It's a 7/16 hole for a 3/8 bolt, so it'd be 0.437. 110 pieces of clips. That's a lot. I don't make more than 2 of anything. I'd get bored quick. This is one of the horizontal angle irons that goes frame to frame, and it would bolt to a frame here and a frame there and one on either end. You get 2 bolts down here, and this, it has to share a clip, so it only has 5 inches of penetration into the middle there. And these are the dimensions from the end to the bolts, and there's a note on how far from the flange that the bolt holes are. It's written up above. That's what a bolt would look like. It's close to this the curved part of the angle in there, so that it'll hold the head of the bolt when you turn the nut. You only need but 1 wrench that way. The center, we're having a procession. Isn't that nice? I forget what it's for. Could be a funeral. I don't know why that dimension's on there twice either. I must have moved it down and copied it instead of moved it. But these are the dimensions for the middle one and the overall length. These are the dimensions for the right side end, the outgoing end. This shoulder is 60 feet long. I think it's 30 feet wide. This was originally designed yesterday for 1.5 inch schedule 20. We call it here GI, galvanized industrial pipe. And we added up the amount of pipe we needed, and the minimum that we could see it advertised was 550 pesos. That's like $11 or something like that each. When you start talking over 100 or something, that gets into real money. And the angle iron we use less of, and because it's much stiffer in the direction we're using it, and we haven't got to buy the like W bolt clamps to put it together with. We can weld these frames. This is a roost for the turkeys. If you got to put it someplace, you may as well put it to triangulate things. If you're going to put it where it'll make it stronger. If it's a reasonable height for what else you're doing. What we got underneath of it? Well, we can do that. A little more than 4.5 feet. You have to duck under that if you're going down one end to the other to put in water and feed and stuff. But this was originally 2 rolled 20-foot long pipes and made the same overall width. So 392 inches. I'm not sharp enough to know what that is in feet. Most of these are square cut stuff, but there's dimensions for them anyway. There's slight variations on these numbers, maybe 10, 12 thousandths. The reason being that I made solids out of them, and I have the point count low, so that it doesn't want to close the ends, and it's hard to snap to the end of the thing and consistently hit the actual end. So it gives me a little bit different number. Okay, this is this one. This is this one. It goes right beside it. I could have made these things a mirror image, and the dimensions would have read the same. But I started on this 5 o'clock this morning, so I just thought I'd go ahead and do this since the internet is off. And we have electricity, so the computer will run. And I have a phone with a battery, so why not? Anyway, there's little numbers here. A few of them, like these red ones and then some black ones. These are maroon. The maroon ones and the black ones, they have a beveled edge on the flange. And these numbers is how much to cut back when to put a mark on it. If I actually go to put this thing up here in October, then what I'll do is I'll use a 2-foot framing square, and I'll put a number for the short leg, which is constant, like 4 inches, and then I'll have a number on the chart, which is the other leg of the framing square, and just mark them with the square, rather than trying to measure that off of holding a square there. I mean, the square could be laying across. We could draw a straight line, then measure over. But it's easier just to give them something they can work with quick. They can use a level and framing squares and all that kind of stuff. And our crew uses every power tool known to man, because we fixed them up. And that would be the bevel on that end. If anybody can see it. And more bevel showing. And the other end, the square ends just lap over down there and right on top of each other, so no need to bevel something that doesn't butt up to something else. Why would you bevel it? This little fella here, he's got these dimensions. You don't need that angle. You can. Suppose, what do we really want here? Okay, wait a minute. That's how much that is cut back. That way it's consistent with the way the other things are all sketched out. If anybody's interested in this thing, just pause the screen and write the numbers down. It's not hard to do. No charge. We're in lockdown with no internet. Bored stiff. This is 2 lengths. I think there's a parting plane in the middle. Yeah. That first one must not been right on the parting line. $27 thousandths difference in the length. That's all right. These are the numbers on how far off the edge of the angle iron that the holes are that bolted all together. This is the little purple clips, and this is the things of 3 different colors. It's the angle irons that go from one end to the other. Now the way this thing works is all this gets stuck together with the flat side of the angles facing down. Like you put a wooden block across here and one under that end and one here and one there. Some kind of thickness. It's like a piece of 2x6. And you lay the stuff down on it and you measure diagonals and you have marked how far in these go. And this is how far up that is, and is it meeting in the middle? Do we have to have a dimension? I pretend somebody's going to ever see one of these videos. Just humor me. And you can, like, the length of this green thing is that. The red one and the blue one, actually, they're the same. That's a dimension. You see they butt into the flange, the side flange of this one. You've got a face flange down and the other one is up, so these can butt into it. Makes a really strong joint for, for angle iron. And we did, okay. I don't know if we talked about that one or not. Yeah, we talked about this because there's the overall expansion, linear. So it's less than 10 feet. 9 feet 6. 9 feet 6 and 5/8. It's a takeoff on a barn roof truss. Well, except that this part here might be a little different. Technically, you don't necessarily have to have this piece here. It could end right there. If it saved a lot of angle iron, I might do that, but we need to put a piece down through here. This one runs length front to back, and rather than just having those sharp edges hanging down, if somebody stand up under and hurt yourself, we just run it all the way down. And also, turkeys like to sit up on things. So we have this piece going across, this one running lengthwise, and that one running lengthwise. Because this is fixed up for about 550 turkeys. And anytime they're not eating or wandering around, they're sitting up in the building. They do it now in the house. We have them living in the house because it's typhoon season. It's all concrete house. If you found this video, there's an icon there that has our channel. If you click on that, there's everything in there from wind turbines to building boats, but there's a lot of videos on some tricks for building houses. This was the stick model. I drew this inside of the rolled round pipe. We have one of those Harbor Freight pipe rollers. We use it on rebar and flat bar, but it's made to roll pipe. It's a different set of dies. Came with it. We have the round dies. We just haven't used them much, except for rebar. We have rolled rebar with the pipe dies. And this is the stick figure, basically. You take your little cross section, whatever you're wanting to do, and you stick it on the end, and you rotate it where you can only see the edge of it. And then it asks, what's it ask up here? Surface, sweep one rail. It's up off the screen, of course. I'm sure it is. Yeah, up where the pointer is up here, sweep one rail. There's also got sweep two rails and some other stuff. About 12 different ways. Anyway, you pick out the direction you want it to go, and then you pick that cross section, and it makes a piece of angle iron from there to there. And then we just whack off the ends where the two meet, and then we got parts. And then you try to look at it in this confusing perspective view and try to figure out which way the angle irons are rotated, whether you've got an edge fitting on something flat instead of the other way around. The way I figured it out is I drew that piece you see laying over there, and then I added these red ones and stuff last. Made it so much easier. Wish I'd have thought of that right off. Oh, assembly. So before I got sidetracked, as I tend to do, I call it wandering off topic or around the topic or whatever. This here is just done flat. All the flanges are down. Okay, so then you take this thing and you flip it over, and that gives you a flat surface that is the right shape to build a mirror image of this thing. You need one for an end that's the opposite of all the rest. So the first one you build is going to be one end or the other. And then you make, in this case, 9 more right on top of the other side. That'll give you 9 pieces. It'll give you a total, because you had the original, 10 pieces like this. okay? So then you put the flat side, which was down, you put it up, and you put these 4 pieces here, these 2 pieces, and this piece, which the flat side going down goes on the flat side of the stuff you've already done. So it's a 2-stage process. The first thing like this has to actually be measured. That's the only one, because you're going to use it for a jig, to make the mirror images, and then these things just match the corners. They match the corner down here, and it lays against this beveled cut. Well, this actually this has a good bit of a opportunity to fudge it without having to move this, because it's in the right place, right where it is. Anyway, make this thing, flip it over, make the mirror images, and these here, left is right and right is left, so you can make the 9 that are alike, and then your original pattern, put the pieces on that, and that gives you the mirror image, because everything is symmetrical. Yeah, I think, oh, one other little thing here. I measured all the stuff in the drawing. The numbers you see down here on the right was these numbers. This is the dimensions. So I just added all these up, got a number for one side. Times 2 is the inches on one side, plus the vertical pole in the middle, which is not part of either side, it's shared. Gives me the total inches divided by 6 meters in inches, and that's how many bars it takes for each of the 10 truss frames. So say 7.5 bars times 10, so that's 75 for that. And there's 11 on the surrounds. If you want all of the roosts for turkeys, it takes 11. You can leave a couple out if you didn't. Times 3, 33. So 73 and 33 is 106 pieces of angle iron. And if I get the guys to knock this thing out, what I'll draw is 234-inch lines or even bars of angle iron. And I'll start moving these things up there and seeing which to cut out of which one to give the least amount of scrap. And I may end up having to buy 3 or 4 bars because I can't get the piece left over isn't enough. My guys use up every little bit of something. So they'll probably stick those end to end. They'll be cut on the miter saw. So if you put them together with about a 16th inch gap, something to weld down to, I'm sure they'll use every inch of it. They're building security grills for the house. Well, one of them's working on it full time now. We had 3 working on it, but they're mostly tacked up. They're artwork. Instead of just having straight up and down bars, I mean, I spent a lifetime trying not to get caught as something to get put in jail for. I don't want to live in a house with jail cell bars. And so my wife says, put something else up there if you don't want it like that. Got to have security grills. Just make them any way that you suit you. And we talked about it a little bit. And hell, she designed the house. She may as well design the windows. We decided we would have themes. So all the outer openings on the floor we live in is things you find on a tropical reef, mostly fish. And in fact, I think it's all fish except for one door. Is a seahorse a fish? So maybe that counts as at least it's aquatic. There's one that's got big leaves because the veins in the leaves and the amount of leaves didn't leave any really open space in the door. So it's a much better security grill than some. And we had one with sharks for there, but it had open spaces, so we just moved it to another place that was the same size. We only have 2 sizes of doors, wide door, narrow door. Wide's like 54 inches, and the other one's like 46 or something like that. Big enough to drive a motorcycle through. I mean, is that Makes sense. Oh, and then the second floor is orchids around the windows and big leaves and stuff for the doors. There's only one door up there. And the inner part of the house is a circular atrium. It's 32 or 3 feet across. That's got a handrail on a catwalk at half height. And that's lotus flowers, a frog, a couple little things. The outer roof at that level, above the actual living space, we have a second, we call our fan deck. And around that out there, there's 5 lanais, and that is, we recycled the fish from the interior doors of the first floor. And that's because it costs 700 pesos per print for the large format print to scale. And that's what they bend the iron and lay it on top of when they make these things. So it's exactly matched to the piece of paper I give them. So far I've been doing the drawing. I just can't get them interested in running the computer. We have a language barrier, and I think they would get frustrated, and they know it, but it's not that hard. If you watch somebody run one of these a little while, you can do it. You don't. It says command up here, and if I wanted to move something, it says object to move. I'll pick an object. Press enter when done. Point to move from. Any point, you can say the end of the thing. Point to move to. Pick a place. Bam. And down on the bottom of the screen, off the screen where you can't see it, it's got X, Y, and Z coordinates, 3-dimensional coordinates, scrolling back and forth. Anytime the mouse is on the screen, you know exactly where it's at, if you want to use that for something. I don't much use that. Well, I do if I can't find something, or if I want to move it to the origin. We didn't look at this. Yeah, this is the instructions on how to put it together. So that you don't have to worry about whether all the angle iron has got a flat flange facing up for turkeys to stand on. That's sort of a common thread amongst the whole thing. At some point in time, when they're smaller, the flange is too wide. When they get bigger, I don't know how they stay up there. But right now, they're on a piece of galvanized 1.5-inch pipe, and like 20 or 30 of them on it, and they don't seem to have any trouble with falling off. Maybe there's so much weight on it doesn't try to turn. Okay. Anyway, if you're totally bored, you can check our channel. You'll be one of the 5 people that watches a video on average. We're not sure there's ranked when somebody searches. If you search our channel name, it doesn't come up. But if you click the icon that's on a video, then the channel comes up. And I'd say that there's numbers through 72 right now, but some of them are 72A and 72B and 59A and B, or part 1, part 2, There's 70. I just did one just before this, is picking magnet wire gauge and number of turns for coils on a stator for wind turbines, how you calculate it, and how you check either side, and how the magnets and the stator work together, and a bunch of stuff like that, all in one video. Hard to find when I was learning how to do it, so I put it all in one place. And wandered around the drawing for the fan, which is, I demonstrated it with the motor for the fan, which is also 3-phase, and we're going to build the exact same stator and magnets and magnet wheels for the generator up on the roof, vertical axis wind turbine. There's a video on that, how to make a booster for the turbine to make an intercept a little over 3 times the air and any air that would be working against the blades, pushing them the wrong way, is blocked. So it's about 6 times as efficient if you just put a vertical turbine up on the roof and stood it up. I don't know how those turn. The differential between the advancing and retreating blades, I guess. Just don't see it making much power. People make them with half barrels and stuff, and they're so amazed they turn. You know, round side versus a cup side. But I don't see them making 100 watts of power out of something like that. And we're thinking more like 10 kilowatts. So, what else is in there? Just a little bit this. How to draw up rebar grids, structural calculations for concrete, skim coating, how to render with reinforcement. This is a fun way to spend an afternoon if you got nothing else to do. Okay, so y'all have a nice day. Thanks for tuning in. If you want to give a thumbs up, you can. I've got about 6 or 7 out of the 7 videos. If you want a thumbs down, I just would like to know with a comment what you didn't like about it, or me, or the color, or sometimes the walk around videos, the camera's shaky. About half our videos are actual taken out of the site, just looking at stuff that's done and being done. And the other half are like this, and also slideshows are actual photographs of the things we do, organized, and they're played on a player here where it doesn't advance to the next picture until you push a little arrowhead, and that lets you, rather than making typed balloons of what you want to explain, you can explain what's in the picture in words. You can just narrate it like we're doing right now. Instead of having a drawing, you'd have a picture. But the rest of it works just like this. And there's like 4 different kinds of presentations. Apparently none of them work. They work as far as make them. They don't work as far as people ever finding them to watch. But I got nothing else to do. Okay, y'all have a great day. Say a prayer to the Lord, and I'll see you later. If I can turn this thing off.